Hi, my name is Rohit, and this is my something impressive proposal. I have two most impressive things done all semester, and one of them is the proposal. So this is where I talked about in the proposal that I needed to overcome procrastination because I thought that was a major factor affecting my work at uni. And in my craftsmanship, I submitted a picture where I actually showed me the amount of I had done, and if I zoomed in on that, you can see that I've only had 20 done. I remember that I had 21 done at that time and around 5 pens left, and I had 50 left to finish in activities. And I thought that was really embarrassing and really bad start to uni. So I went ahead and went to fix that. And if I look now, at this point now, I got 79 completed with 6 penders. Some of them will be marked by the tutor year. So that will be around 85, 83. So 80 completed compared to where I had 20 completed before is definitely something which I thought was impressive. It was a dramatic change for me, and personally I think it was very hard course, and I thought that getting up to this point, yeah, doing my own code, programming every activity I can whenever I can, get to that point was really impressive. Now, that wasn't the most impressive thing, however. The most impressive thing which I thought was working with microprocessors. I realized when doing the online microprocessors, I realized that Richard gave us these functions which he made up, and it wasn't very realistic or applicable to me in real life. So what I did was start working with these ones. This is the microprocessor you see now is the Atmega 1280, and it's a very useful device, and it's one of the ones that I borrowed from uni, which we actually use there. It has a 4x4 keypad and has 8 LEDs over here, and has the buzzer which basically emits sound, 7-segment display LED over here with 4 parts, and many other parts which are very useful. So I started playing around with these, and one of the first programs I actually used to program the controller was the buzzer. So basically just switching on and off the buzzer. So every time the program runs, it just switches on. That's basically it. Because that was too easy, I thought I'd go a little harder, and what this does is actually, this program here just switches it on every 500 milliseconds, and leaves it on for 500 milliseconds. So what happens is I first set the data direction register and then the ports to the buzzer, and then set the timers and interrupts, which calls a function every interrupt, which is interrupt service routine function, and toggles the buzzer output. So basically just switch it on, delay it, then switch it off again. And that's basically it. That was one of the simple programs. One of the ones which I worked with a little harder was the LED walk. So basically it looks like this. So it goes from one side to the other, and that was actually a lot of fun. So basically it just goes from one to the other place. But what in this program what it does, it just goes from one, waits a second, then goes to the next one. It goes all the way to the end, and then once there's no more to go to, it resets from the start again. So that's the LED walk. And so basically just initialize the board, and we disable interrupts, then initialize the LED array. So that's where we set the data direction register as 1 as the output, the LEDs. So setting all of them to 1, that's 1 for 8 bits in hexadecimal, and ports all to 0. So just switching off all the LEDs. And once we do that, we initialize the timer, which is setting the function here, initialize timer to a prescaler. So just setting all the timer values, setting the compare matches and the interrupts. So every time we interrupt, we call the ISR function, the interrupt service routine, and then set the time steps. So what we do here is we get the computational clock and convert that into real time. So every 112 cycles in the clock, we mod that and get a value for that. And that's approximately to 1 second. So every time we get to 1 second, we set the LED array flag to 1. And once we initialize everything, then we go back to the while loop where we infinitely loop the function. So, and we just keep on checking whether the LED array flag has been 1 or not. So every time it reaches a 1, every time it reaches a 0, then we shift the LED from left to right. So if you go to the function where it shifts from left to right, we can see that we set the max as 80 in hexadecimal, and that in binary is just setting the 8th LED as 1. You can think of the 8 byte number as each LED. So it's off, all up to 1. And that's basically what it does. So that's what I did here. And then you got the temp, which is the current value now, where you make that kind of current value, the current LED switched on. And then if it's past the max or the temp equals 0, then we switch on, we make the LED port back to the starting point, which is 1, which is the first one. Else, then you just shift one, you make the next byte from temp, shift it left once to 1. So you see until the left 1. And then that's all it does. So it's just shifting, so this is what it will look like. Just going from this point here and goes to other point. So waits 1 second, starts at this point here, waits 1 second, goes to the next one, 1 second, 1 second, and so on. Let's go to this point here, it's the flash back to the 0, back start again. And that is my most impressive thing I thought at all for the entire semester, for all my subjects to be honest. And this was a lot of fun, and I hope this was great for everyone else as well.